today? Were you absent today? Did you sleep in? Do you just need to see a couple of those examples again? The free problems that we basically did in your workbook. If so, this video should hopefully help you, okay? Just to give you a quick heads up, this is section 8.3. If you ever happen to take a look inside your resources on your online textbook, we are in section 8.3, so that is where you can get this info from. We are talking about exponential growth and decay, okay? That is what we're talking about, but we're actually going to be doing word problems and talking about money and that sort of thing in lesson 8.3, okay? Two examples, and these are just two examples, but two examples of an exponential growth or decay. One thing is that I wasn't sure how many of you know, if you buy a box van, because apparently that's what this looks like. If you buy a car, right, the second you drive it off the lot, it actually depreciates and it decreases in value. Usually it will depreciate by a rate, okay, a certain rate. That rate is usually given in percentage. The more you drive it, right, the more the car is going to depreciate in value. And so that is an example of a decay, an exponential decay. A lot of times, and this is obviously not including like the whole housing crash that happened, I don't know, 10 years ago or so, but a lot of times houses will increase in value or will appreciate, okay? And so this is an example of an exponential growth. A couple of other examples really quickly. Let's say you had a deer population and it's hunting season. The deer population obviously is going to go down, okay? And so, again, if it's hunting season and you're looking at, hunting deer, that population might decrease, okay? Maybe there are some frogs that are living in a pond near you or something, and frogs multiply, right? They increase at a certain rate. That would be an example of an exponential growth, okay? The formula that you're going to use for that is going to be this one. So A equals P, and then 1 plus R to the T power. That is for an exponential growth. If it's an exponential decay, you're going to subtract instead, okay? A is going to be the amount you're going to have at the end. And at the end of what? At the end of T time, okay? So A is going to be the amount that you're going to have at the end. So let's say that your frogs are multiplying and you want to know, okay, if the frogs keep multiplying the way they are in about 2 years, how many frogs am I going to have, okay? All right, P is going to be what is called the principal amount. And I think it's LE. One of your classmates told me it was LE. I wrote AL, but principal, we think, is like what Miss Yolanda Flores is, right? She is a principal of school. But this is the principal value or the initial value, the starting value, the amount of money that you put in, okay? The number of frogs you start with, how much money your car was worth when you bought it. Okay. And then last but not least, R is going to be the rate. I will tell you that with the rate, it is almost always given to you in terms of percent, and you are going to have to change it to a decimal. I will also tell you that this, as easy as it sounds, is usually where a lot of mistakes can get made. Okay. All right. Let's do a quick example. Okay. All right, I got deer on the brain, probably because that was the example that we did in class, so let's do that one. So let's see, we have a population of deer, and there are 1,500 deer right now, okay, so there's 1,500 deer, and those deer are decreasing by 1.5% each year, okay? what I want to know is at the end of 10 years, and I apologize for my abbreviating, but at the end of 10 years, about how many deer will there be? Okay, how many deer are there going to be? It's hunting season. People are, hitting them with their cars, that kind of thing, right? And so the population is decreasing. I don't know. The global warming, they don't have enough food to eat. Who knows what the issue is? But after 10 years, if this keeps steadily decreasing by 1.5%, how many deer are we expecting to have? Okay, so according to this formula, right, A is the amount at the end of the time. And so that's what we're asking. That's what we don't know. P is the initial value, the principal amount. And so we start with 1,500 deer. Okay. Then because we're decreasing, we're going to do 1 minus. And then again, here's where that tricky part comes. So the 1.5%. If I take 1.5% and write it as a decimal, remember your decimal place goes 2 places to the left. So it's 0.015, okay? And we're going to raise it to the 10th power because we're looking for 10 years. Now comes the other tricky part, and that is, can you type it into the calculator? Okay? If you have this calculator, you can type it in exactly as you see it, literally 1,500 parentheses and on. If you have Desmos, you can do that. But if you're using your cell phone, maybe, and then you're like turning it sideways so you can get the scientific part, so you can do the to the 10th power, you're going to have to type things in step by step. So that's actually what I'm going to do right now, just in case that's the kind of calculator you have, okay? So order of operations, you're going to do parentheses first, so 1 minus 0.015. Then you're going to raise that to the 10th power, and then you're going to multiply by 1,500. Okay? And you get an answer of 1289.6. Now, here's the other part that's weird, okay? We are talking about deer. This is my stick figure for deer, okay? We're talking about deer. We're talking about Rudolph, right? You can't have 6/10 of Rudolph, right? There's no just Rudolph's legs hanging out somewhere, okay? So you want to make sure that your answer makes sense. So you're going to round to the nearest animal, okay? And so that would be 1,290 deer, okay?